So hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own mascot at the side, and today we will be solving a 54th day problem of the day. And today's topic is minimum distance between two given nodes of a binary tree. Okay, let us have a look at the problem. Okay, so this is a problem. Okay, what has been asked that we will be given two values, name it as a and b. These are integer type values. It is mentioned in the question that all the nodes have unique values, that is all the values are distinct, and the values given to us, that is a and b, are necessarily present into the tree. Okay, we have to locate those two nodes which contains a and b and then find the minimum distance between a and b. Okay, for example, if I consider a and b as 8 and 9, so I can locate that 8 is coming here, 9 is coming here, right? So to move from 8 to 9, I will have to take how many steps? I will have to go from 8 to 4 and then 4 to 9. That is 2 steps, right? 1 plus 1 gives me 2 steps. Correct? All right. If I see for 8 to 10, for 8 to 10, I will have to go from 8 to 4, 1 step, 4 to 2, 2 steps, 2 to 5, 3 steps, 5 to 10, 4 steps. All right. So it will be 4 steps. Correct? Now from 8 to 2, 8 to 4, one step, 4 to 2, two steps, right? For 2 to 12, so 2 to 1, one step, 1 to 3, two steps, 3 to 6, three steps, 6 to 12, four steps, right? So 4 steps. Same for 2 to 11, 2 to 5, one step, 5 to 11, two steps, right? 2 to 15, this is the last node. 2 to 1, one step. 1 to 3, two step. 3 to 7, three steps. 7 to 15, four steps. Correct? If you find it anything discrepant, please engage him in the comment section, and we will work prosper from that knowledge. Now for 2 to 7. So 2 to 7 will go 2 to 1, one step. 1 to 3, two steps. 3 to 7, three steps. Right? I have mentioned the minimum number of steps here, right? These are your answers. So I think we are clear with the what is input provided to us. Input is a binary tree, an integer a and integer b, and output as we discussed right now, right? So what should be our approach? That is the main thing to do when we are solving a question, right? To maintain a streak, to learn something, we have to solve the question. What should be our approach? Our approach is, you will see that bhaiya, if I, instead of a binary tree, it was a graph, then I could simply travel from A till B, a BFS traversal, and return the answers. Correct. Your approach is absolutely correct. So my first approach would be to convert this binary tree into a graph, right? Into a undirected to directed, that is your say, into a graph, and then do the same A to B BFS traversal. All right. But I say this is my brute force approach for you guys, right? Comment me if you have got a better brute force approach. All right. But let us assume that we have to solve it more efficiently, right? So while I was going from 8 to 9, I observed that I have to go from 4. While I was going from 8 to 10, I have to observe I have to go from 2. 8 to 2, coming from 2 only. 2 to 12, I was going through 1. 2 to 11, I was going through 2, right? 2 to 15, 2 to 15, again I was going from 1, right? And 2 to 7, again from 1, right? So 8 to 9, 4, 8 to 10, 2, 8 to 2, 2, 2 to 12, 1, 2 to 11, 2, 2 to 15, 1, and 2 to 7, 1. These are the values. If you focus here, the lowest common ancestor, the lowest common ancestor. I hope all of you have heard this term pretty well, because this is a basic DSA question. If you are not familiar with this question, don't worry, we will be discussing here. Okay, what is the lowest common ancestor? As the name suggests, a node A, B, right? A is in the left subtree, B is in the right subtree, then this is my lowest common ancestor. This is the simplest definition. where the two nodes meet, the two parts meet, right? So 4 is the lowest common ancestor for 8 and 9. 2 is the lowest common ancestor for 8 and 10, so forth and so on, right? So it can be related that if I find my distance of this node, let us take an example of 8 to 9. 8 to 9, distance from root 1, 2, once I have to move to 2, 2 to 4, 4 to 8. That is 3. I have to move 3 steps to go from root to 8. For 9, I have to go 1, 2, and then 3. Again 3. And for 4, I have to go 1 and 2. Right. So I have 3, 3, and 2 in my hand, and I have to reach 2. Alright. One possible thing I can do is 3 plus 3 gives me 6, and 2 into 2 gives me 4. So I say 6 minus 4 is equals to 2. How did I reach here? I say to get this 3, I have to traverse 1, 2, 3, right? And to reach this 3, I had to traverse 1, 2, 3. And to reach this 4, I had to travel 1, 2. Now, to get this distance, let me change the ink. To get this distance, I have to subtract these values 1, 2, 1, 2, right? These three were coming from these values, right? So for that, I am subtracting these values that was coming from 4, right? And that has to be subtracted two times because it was coming two times. Okay, 6 minus 4 gives me 2. This is the only clear approach. Let us try it for another examples also. For 8 to 10, for 8 to 10, 8 distance as calculated 3, 10's distance is 1, 2, 3, again 3, and the common ancestor is 2, 2's distance is 1. So 3 plus 3 gives me 6, minus 2 into 1 gives me, minus 2 gives me 4, again matching. Okay, for 8 to 2, lowest common ancestor is 2, 1, 2, 3. All right. For 2, 1. Right. 2 distance is 1. So 3 plus 1 gives me 4. And minus 1 into 2 gives me minus 2. That gives me 2. Again matching. Rest of you is a homework for you. Do it on your own and practice. In that way only you can enhance your knowledge. All right. So the basic thing I have come up across is I can solve this problem if first step I find my lowest common ancestor, which is known as LCA in the short form. Sorry for my C here. Second, find distance of A. A is an integer value, right? Name it as A. Third, find distance of B. Name it as B. Fourth, find distance of LCA. Name it as C. And return, what I have to return? A plus B minus 2 into C, right? This is your whole code. This is your whole pseudo code. These are the main steps, all right? If you know LCA very well, just code down the LCA and move the distances, and then you have your answer. If you don't know the LCA, stay with me. Now I will be explaining the lowest common ancestor. The lowest common ancestor. All right. So guys, if I ask you the lowest common ancestor of 3 and 5 here, what is the lowest common ancestor? You can see the 3 and 5 meet at 1, right? So if I ask the steps to reach 3 through root, so it will be 3 coming from 2, coming from 1, right? And 5, for 5 it will be 5 coming from 4, coming from 1, right? Suppose the tree goes extended as 2 and etc., something like that. Then both of them will add, let us say it is 10, right? So it will be 10 here and 10 here, correct? So I see the lowest common ancestor is if I traverse it from this side, the lowest common ancestor is the last node which is common, right? 1, 1, correct? So in this case, my answer would be 1. For this, If I try to find the lowest common ancestor for 4 and 6, you will see that 4, the 6, suppose root is 4 only, so 6 path will be 6, 5, 4, and 4's path will be only 4. Traversing from this side, 4 is the lowest, that is the 4 is the last common thing, so 4 is my answer here. Alright. So one algorithm to find the LCA is find the path and then find last common value node, right? This is the first brute force, I will say that efficient but using space. I will try to solve it without using space. Yeah, obviously the recursion stack space will be there, but without any storing the nodes space, right? Storing the path space. So what I will do is I am saying that if you're standing at some root, there are four possibilities. What are the four possibilities? One of them is my root is null. If my root is null, I cannot do anything, return null, correct? The second part is my root's value is equals to A or equals to B. So if I'm standing at my root and my A is here, correct? Then it has to be pretty evident that B is somewhere here only, right? In this subtree only. So my lowest common ancestor for this will be A. So in that case, return this root only, right? My third is that A is present in the left subtree and B is present in the right subtree, third subcase. So in that case, my left will be find the root in roots left A and B, right? If my left is equals to null, only then find right, right? Do the same steps for right. If done, then return right. If right is not equals to null. If both of them are null, in that case, return root. That is this case, return root, right? Hope you find it interesting. Hope you find it knowledgeable. How we find the LCA. If you are not, please rewind the video and watch it again. The main objective of this video is not to find the LCA, but it is to solve today's GFG Hope you understand that. I will make a video in the near future for the LCA only. Please stay connected, and if you have not subscribed, subscribe to my channel, and don't worry about that. So let us code it down real fast. I think the video has been getting very long, so let us just code it. So what did we do? My node star LCA will be, I will define a function find LCA. Let me zoom it down. Find LCA, I will send root with my two values, right? This was my first operation. Now, my capital A was distance of A from root, right? Currently 0. This is a helper thing. Int B equals to distance of B from root, and int C was equals to distance of LCA from root. LCA data I will have to send because of the integer type, and then I have to return A plus B minus 2 star C. This was clear to you, right? Just have to code the LCA first and then the distance. So node star find LCA taking node star root int A int B, right? First case was if my root equals to null. In that case, return null. Other case was if my roots data equals to A or roots data equals to B. In that case, return root only. Correct? These were the steps. Now my node star left equals to find LCA for roots left with these values, and my node star right equals to find LCA for roots right. Now if my left is equals to null, return right. If my right is equals to null, return right. Also return left, sorry, in this case. If both of them are not equals to null, in that case return root. Right? This was my code for LCA. Now let us code down the distance function. So int distance, it was taking my root, my value, and my current distance, that is 0 d. Right? If my root equals to null, in that case return -1. Correct? If my roots data equals to a, in that case return d. Correct? Otherwise find in left and right. So again my int left equals to distance of roots left for a. Now d plus 1 here because we are moving down, so int right equals to dist of roots right with a. Again moving down, so increment your d. Now if my left is not equals to -1, in that case return left. If my right is not equals to -1, in that case return right. Otherwise uh, return -1 only, because we're not able to find in left either in right. Right? So this is my whole code. Hope it works fine. And it is running fire for compile and run. Let's try it for submit also. In the meantime, please subscribe to my channel. Your subscription means a lot of motivation for me. And if you like the video, please do drop a comment, engage with me, connect with me on my Discord, and keep coding. Stay safe. Meet you tomorrow. Till then, have a nice day.